This lesson looks at circles. The general equation for a circle, if its centre is at 0, 0, is x squared plus y squared is equal to the radius squared. Now, the reason for that, well, look at this circle. What we do is we draw in a radius and then we make a right-angled triangle with the x-axis from that. So what we know is that this length here is r because it's the radius of the circle. And then if you look at this length here on the bottom of our triangle, you're going to get x, because this point here is xy, and the height of the circle, well, that's going to be y. So then what we have is this right angle triangle, and we're going to use Pythagoras' theorem, and that tells us that x squared plus y squared is equal to r squared. And that applies to any point around this circle. Wherever I move that point, xy, it's going to be exactly the same. So that's why the formula is x squared plus y squared is equal to r squared. So looking at this example, we're asked to sketch the graph of x squared plus y squared is equal to 16 and state its domain and its range. So x squared plus y squared equals 16. So 16 is your r squared. So therefore r is equal to 4. Now we don't have to consider negative because we're talking about the radius of the circle and it can't be a negative value. So if our centre is at 0, it's going through all the points that are 4 units away from that. So it's going to go through 4 on the x-axis, 4 on the y-axis, -4 on the x-axis, and -4 on the y-axis. Your centre is at 0, 0 because it's x squared plus y squared, and then you draw your circle. So once you know all of the points that it goes through, you can work out your domain and range. So the domain is all of the x values that this exists for. So the domain, well, x runs from 4 to -4. So that's your domain. Well, what about your range? Well, it's exactly the same really, isn't it? So it goes between -4 and 4. And that's how you sketch the graph of a circle. But what if we move the centre? Our equation is going to change then, isn't it? So say I have this circle here, and I'm going to say this centre has the coordinates AB. Okay, so that point, the edge of our circle, is still going to be xy. The radius is still going to be r. Well, the sides of our triangle are no longer just x and y, because x and y is all the way out here. That's not going to tell us the length of the side. But if you have a look, what we have is this point here has an x-coordinate x. This one here is a. So the distance in between them is going to be x minus a. So that means the length of this side here is x minus a. And it's going to work similarly for y. This one here is y, this one here is b. So that distance is going to be y minus b. So again, using Pythagoras, we're now going to get x minus a all squared plus y minus b all squared, and that is going to be equal to r squared. That's what Pythagoras tells us. And that's how we come up with the formula for a circle. So let's have a look. We're asked to sketch the circle x minus 4 all squared plus y plus 2 all squared is equal to 4. So whenever you get one of these equations, you first need to work out where is the centre. Second, you need to work out what is the radius. From there, you start figuring out some of the points on the circle. So x minus 4 all squared means the x value for the centre is 4, and y plus 2 all squared means that the y value for the centre is -2, and our radius, square root of 4, so our radius is 2. So looking at this axis, we know that our centre is at the point 4, -2, so mark that in. And then we know that from the centre, the radius is 2. So once you've got the centre, go up 2 units and put a point, go left 2 units and put a point, down 2 units and right 2 units. As long as you've got a couple of points and then you can sketch a circle within that, you'll be just fine. Now this is going to test my abilities because I'm not good at doing this on the iPad, but here we go. Haha, not too bad at all. So that's how you sketch the circle. Now the 2010 HSC question was write down the equation of a circle with centre -1, 2 and a radius of 5. So this is pretty much as easy as it's going to get, guys. You start off knowing that the centre isn't at 0 means that we're going to use the x minus a equation. So we get x, now it's minus 1, so that makes it +1 all squared, and then it's going to be y minus 2 all squared, and it's equal to the radius squared, which you then just tidy up. So x plus 1 all squared plus y minus 2 all squared is equal to 25. Don't expand it, guys, because you get less information from the expanded form. Knowing that it's factorized like that immediately gives us the center of the circle, which is a really important piece of information. So leave it factorized. Next, we look at semicircles. So each of those circles that we looked at so far, they're not functions, because if you draw the vertical line, it's going to cut the circle in 2 places. But the circle is made up of 2 separate functions. The part above the axis, which if you try to solve for y, you end up with y is equal to the square root of r squared minus x squared. And then the part below the x-axis, which is minus the square root of r squared minus x squared. So when you're asked to sketch something like this, so f of x is equal to the square root of 9 minus x squared, what you will hopefully be doing is looking at that and going, hang on a minute, we've got the square root, we've got an x squared, this is a semicircle. Once you know that it's a semicircle, you need to look at it and say, well, where is the centre? We've just got an x squared, which means the centre of this circle is at 0. So from there we need to know what is the radius. And the radius is going to be the square root of 9. So the radius is 3. So it's going to go through the points 3 and -3. And then you need to say, are we looking at the semicircle above or the semicircle below the axis? And in this case, it's a positive square root, so we're looking at the one above. So you mark in your intercepts. Your intercepts are -3, 3, and 3. And then draw your semicircle. And pretend I did that through the point that I marked as 3, and everybody will be happy. So looking at that, what's the domain of this function? Remember, the domain refers to the x values that it exists for. So the domain of this function here is x lies between -3 and 3. And the range is the y values. We'll look at the y values. Where does y exist? Well, y is between 0 and 3. Now, if there'd been a negative in front of that square root sign, it just would have been the other half of the circle, the one below. That's what you need to do, 5.8. Do some of each question again, okay? And if you're having trouble, do a few more from that question before you move on. Good luck, and I'll see you in class.